Yes. Hello everyone. I'm going to go through this coursework, and here was the instruction as we're instructed to present each of the question, make the video recording of this presentation, and we post this work on our day, like we post the links. This coursework is for the operating systems as our course unit. We're going to first look at what is operating system. An operating system is a system software that manages computer hardware, software resources, and provides a common service for the computer program. We're also going to see what is amount storage management, and this refers to various technical devices storing large amounts of data. And modern mass storage devices include all the types of disk drivers. We're having the input-output system terms, where we are having a port, and a port is a computer. Port is this is an interface or a point of connection between the computer and its peripheral devices. So in computer communications, ports can be divided into two based on the type or protocol used for communication. That is a serial port and a parallel port. We are having a bus. A bus is a network. A bus is a network topology or a such arrangement in which all devices are attached to a line directly, and all signals pass through each of the devices. And here, each device has a unique identity, and it can recognize signals intended for it. And this bus communication system transfers data between components inside the computer. You're having the device drivers. Device drivers provides a software interface for hardware device, and this enables operating system and other computer programs to access hardware functions without needing to know precise details about those hardware being used. Generally, a driver communicates with a device through the computer bus, which connects the device with the computer. We are having a daisy chain. A daisy chain, which refers to connecting all the devices that can request an interrupt into a serial manner. So here, the configuration is governed by the priority of the device, and the device with the highest priority is placed first, followed by the second highest priority device, and so on. So what a daisy chain does here, it acknowledges the CPU interrupt by sending the ISK 3.1 input-output device number 1 receives acknowledgement 3.2, and the operating device inputs its information on data line 3.3, and the CPU here understands that and runs that specific request that has been submitted. And this, what does this daisy chain mean? It could be like a link in the operating system. So you're having pooling. Pooling is a resource management term that refers to the grouping together of the resources. So, in pooling, resources can refer to system resources such as the file handlers, which are external to process all internal resources such as the objects. We're having a buffer, which is a memory area that stores data being transferred between two devices, or between a device and an application. In a buffer, data is stored for a short period of time. Data is stored in a short period of time, either between and in other words, buffer temporarily stores data transmitted from one place to another, either between two devices or an application, and this act of that data temporarily in the buffer is called buffering. We are having spooling. Spooling is the method of storing data temporarily in a memory area so that a device or a program can use it. In this program or a system, data is sent to and stored in a memory or other virtual storage until the program or a computer requests it for execution. Spool is a acronym for simultaneous peripheral operations, and one of the advantages of spooling is the pool buffer provides a waiting station where data can rest while a slow device. This includes the printers that catches up. When the slower device is ready to handle a new job, it can read another batch of information from the spool buffer. And we can see how does spooling happen. Here, what I can tell is printer spooling. I can give you an example of a printer spooling, and it enables you to send large document files or series of them to a printer without needing to wait until the current task is finished. Think of it as a buffer or a cache. It's pressed that your documents can line up and get ready to be printed after previous printing task is completed. We are having another question which says how the direct memory access increases system concurrency and how it complicates hardware design. First, we are going to see what is direct memory access. This is a feature of a computer system that allows certain hardware subsystems to access main system memory independently of the central processing unit. So in the direct memory access, increases the system concurrency by allowing the central processing unit to perform tasks while the direct memory access system transfers data via the system and memory buses. Here we can see how the GMA complicates the hardware design. This is because the direct memory access controller must be integrated to the system, and the system must allow the direct memory access controller to be a bus user. And a cycle stealing may also be necessary to allow the central processing unit and the direct memory control access controller share the use of this memory bus. Here we're having the advantages and disadvantages of placing functionality in a device controller. Advantage 1. Particular frames are dedicated for the input-output devices. Next, it frees the central processing unit to process other tasks. Data is being copied to and from some devices. That is, the direct memory access requires a special controller which handles all the input-output requests for the CPU. It also allows the parts of the operating system to communicate with this layer without having to know anything about that particular device. Then the advantage is number 1, the communication between a fast central processing unit and a slow device, or between a fast central processing unit and a device using a slow bus, can be a bottleneck for the whole system, like it can fuse the whole system. Another advantage, the direct memory access complicates the hardware design because it shares the memory bus with the central processing unit, and the controllers must directly access physical memory at the same time that the CPU may be accessing physical memory. We are having the detailed description of mass storage scheduling algorithm. But we are going to first see what is the disk structure.